Okay, so we go for 18. We see what's the problem here. They're giving us a formula. They say y coordinate is finding by this equation. So a curve is forming by y equals to ax squared bx plus c. So a, b, c are constant. They say this quadratic graph, this quadratic curve pass through 3 points. So when it said can pass through these 3 points, means that our point can be fulfill this equation, our point can be substituted into this equation. So we have the first point to substitute, second point to substitute, and third point to substitute in our equation. So by using the information above, we have to construct the linear equation first. So we have to come up what's the equation they give us. So for the first point, when we substitute our x equals to 2 here, we will get 2 squared, so equals to 4a. And then substitute here 2b, and then plus c. What's the y coordinate? Y coordinate is 11. So this is how we form our first linear equation. Secondly, for second point, we put in our x squared here, it will become negative 1 squared, which is 1. Therefore, we get 1a. Then negative 1 we put here, we get negative b, c, and then coordinate y is equal to negative 16. So I just rearrange the coordinate y to the right hand side. So for the third point, x with 3 we put in will be 9a, and then 3b, and then plus c, which is equal to 28. So this is how we form out our 3 linear equations. So 3 marks here. So the first one is the concept where you know that the point can be substituted inside this equation to form out a linear equation. And then for the first, if you manage to get these 2 linear equations, we get your answer for the first answer marks, and everything is correct, we give you another marks here. So you will total up 3 marks. So for question B, they ask us to express above system here in a metric equation. So we have to form out our matrices, where our first matrices here is about our coefficient. And second matrices here is our unknown. So our unknown is A, B, C. And our last matrices here is our answer. So this is what the meaning of the metric equation. A x equals to B. So A is the equation for this coefficient, which is 4 to 1. So 4 to 1 times your unknown, we get 11. So second equation is 1, negative 1, 1. And then the equation here is 9, 3, 1. And then our answer here is equal to 11, negative 16, and 28. So we can know that this is our metric A. Now it is denoted by this is metric A, this is metric unknown, this is metric B. So this is just 1 mark because expressed in the answer like that, in the metric form. So this is only 1 mark. Hence, we are going to find this inverse of A. So when you want to find this inverse of A, we have to refer back how many methods we can use here. So actually in our inverse, we have 3 methods to find the inverse: adjoint, ERO, or properties. So for this question, they will mention using adjoint method. So they are pick adjoint method. If we doing other methods, they will not be accepted. So if adjoint method, you can find the inverse metric using adjoint method. So means A inverse will be equals to 1 over determinant A times adjoint A. So first of all, I want to find out what is the determinant A. So determinant A, we are expanding using first row. So it will be element 4 minus 2, then plus 1, Then when we cancel off, when we eliminate first row, because this is A11, right? So position 1, 1. When I cancel off, I left negative 1, 1, 3, 1. So copy and paste, in and out. Those vertical is 1, 9. So we're going to find here what is your AD minus BC, negative 1 minus 3. Then cross multiplying here, 1 minus 9, and then here is 3 minus negative 9, so negative negative become positive. So my determinant equals to 12. So this is not a singular matrices, it got inverse. When it has determinant means it got inverse. Okay, so from determinant concept, we'll get 2 marks here. One is how you're expanding using first row and how you get to the answer. Then we'll continue to get adjoint. So before I getting adjoint, I have to find out what is our core factor. Because adjoint is equals to core factor transpose. So core factor is plus or minus for our minor for every position. So for every position, this position is negative minor, this position is positive minor, this is negative minor, then positive, negative, positive. So core factor is adjoint is equal to core factor transpose. Core factor, if I want to get core factor, is your plus or minus minor. It is depends on your position. Okay, so what is minor? Minus is going to eliminate row and column. So we are doing row by row. So I am doing A11 here, position 1, 1. Row 1, first column. So eliminate first row, first column, negative 1, 1, 3, 1. So for the entire row, 1, 1, negative 3, negative 1, 3. And then those vertical is 1, 9, 1, 9. Then we repeat again for position 2, 1. So entire row I can do for 2, 1. Eliminate 2, 1, I get 2, 1, 3, 1. So copy paste, in, out, and then we see what is vertical. If I cancel this and cancel this, those vertical is 4, 9. So 4, 9, 4, 9. So of course I cannot effect the answer there, so I have to route off there. Okay, so we continue for row 3. So when I eliminate this row 3, 3, 1, I get 2, 1, negative 1. Negative 1, 1. So copy paste, in, out. Those vertical, when you close your row 3 and 1, so leaving the most vertical which is not cancel out is 4, 1. So therefore, we can simplify our minor here, which is AD minus BC, in order to get our core factor. So negative 1 minus 3, here come negative 4. Here 1 minus 9, will become negative 8, but in front here got negative, it come back positive. Then this one 3 minus negative, so negative negative become positive 12. 2 minus 3 negative, negative negative positive, and then 4 minus 9 negative 5, and then this one 12 minus 18, so it become negative 6, but in front got negative become positive. So 2 minus negative 1, so it become 3. Then 4 minus 1 become 3, got in front got negative. Then lastly, -4 minus 2, then -6. So this is our cofactor. Then we can get to our adjoint, which is cofactor transpose. Transpose means we were going to do our row in column. Transpose means exchange their position. How to exchange? Row become column, second row become second column, third row become third column. So this is our first row become first column, second row become second column, third row become third column. So we get our adjoint. Okay, so we continue. After we getting our cofactor, we getting our adjoint. So I can find the inverse of A using adjoint. So our A inverse will be equals to, we plug in our determinant here, 12, and adjoint matrix here. So make sure you do the multiplication. Multiply in our 1/12 here inside to this every element and simplify it as fraction. Okay, so this is our first task, which is finding our inverse of A using adjoint method. Hence, we are going to solve what is our ABC. Okay, so in order to solve our ABC, then I have to look at our unknown matrices here. Our situation is giving that AX equals to B. So in order to find our X, so we have to use the properties how to clear off the X here. We will time A inverse in front. So when we time A inverse in front, A inverse with A, we get identity. Then identity times unknown matrix, you will get unknown matrix. So that's why unknown matrix is equals to A inverse times matrix B. So we will plug in our inverse matrix here, plug in our unknown matrix here, and plug in our matrix B in order to find out our unknown matrix. So therefore, unknown matrix here is A, B, C. Inverse matrix A and time with our matrix B there is equals to 11, -16, and 28. So from here we can get to our answer 2, 7, -11. So don't forget we take out the value where A is equals to 2, B is equals to 7, C is equals to -11. So this is how we do our solving using adjoint method, using matrices. So we continue. For our cofactor here, we will giving you a concept marks in order to get to the adjoint where is transpose concept, and when inverse, this is how we do determinant times adjoint matrix to get to the inverse matrix. So when we have solving, we get A inverse time with our B, and we take out our answer from matrices. So 1, 2, 3, 4, 5, 6, 7, 8.